A very good day to you. Welcome to our presentation for today. I'm going to present about stack data structure. Let's get to know in detail what a stack data structure is. When we define a stack data structure, it is a linear data structure that follows the principle of last in, first out. When we say the principle of last in, first out, we are saying that the last element that has been added into the stack is the first element to be removed from a stack. I can give you an example. If you put books on a table, if you want to put a heap of books on a table, you put the first book, then the second book will come after the first book. When the third book will come on the top of the second book, then the fourth book will come on the top of the third book. Meaning that when you want to remove the books, you first remove the book that is at the top, meaning that the last book that you have added will be the first book that you will remove. So a linear data structure, it stores data in linear form, just like arrays and maybe queues and linked list. So let's get and understand something that is very important. Properties of stack structure. The stack data structure has the following properties. All insertion and deletions occur only at the top of the stack, meaning that the last element that you have added into the stack will be removed from that stack, right? You don't have to first remove the first element, but you first remove the last element. And also, when you want to add an element, you add an element at the top of the stack. Then the elements are removed from stack in reverse order in which they were inserted. So you inserted 1, inserted 2, 3, 4, 5. Meaning that when you want to remove the elements, you have to remove the elements starting from the last one, which means you are going to remove 5, 4, 3, 2, and 1. Then another property, only one element can be pushed or popped from the stack at a time. It means that when you want to insert or when you want to remove an element from the stack, you have to insert or remove one element at a time. Then the last property that I have is that it works in last in, first out, or LIFO manner. That is last in, first out. That is what I was saying when I was starting. Now let's understand the LIFO principle in this way. In programming terms, putting an item on top of the stack is called push, and removing an item is called pop. So push will be adding an item, then pop will be removing an item from the stack. For example, over there I've got 5 containers. The first container is empty, meaning that it will be representing the empty stack that is on the on my left. Then the second container, we are inserting an element. We are inserting 1 into the container, meaning that we are applying the operation that is called push. Then on the third container, meaning we are adding another element. We are adding element 2, meaning that we are pushing right into the stack. So of course you can see that we are pushing, we are adding an element at the top of the stack. Then for the fourth container, we are adding element 3 into the stack again. But let's go to container number 5. We are removing an element from the top of the stack, meaning that we are popping, we are using the operation that is called pop. Then for the basic operations of stack data structure, I would like you to understand the following basic operations of stack data structure. The first operation that we must know is push. Push means that it is adding an element on top of the stack. Then pop remove an element from the top of the stack. Then the third operation is empty. Is empty, check if the stack is empty. Then is full is the fourth operation. It is just used to check if the stack is full. Then the last basic operation I have is pick. Pick is used to get the value at the top of is used to get the value at the top element without removing it. So we are accessing the top element, but we don't have to remove it. Those are the basic operations of stack data structure. Now let's understand something that is very, very important. When working with stack data structure, what do we do? The operations work as follows. A variable top is used to keep track of the top element in the stack. Sometimes it depends on type of the program that you are using or type of the way that you are using for the program. Some they use pointers, so they say that the pointer called top, so the pointer called top in that is the one that will be used to keep track of the top element. But over there I just used the variable. The variable top is used to keep track of the top element. When initializing the stack, we set the value of top to what? To -1. When we set the value of top to -1, it means that the stack will be empty. But when we compare the value of the variable top to -1, it means that if we compare it to -1, it means that we are checking if the stack is empty. And also again, we can, when we push an element or when we add an element into the stack, the value of top will increase. But when we remove an element from the stack, the value of top will be reduced. So that is how it will be like. So I would like you to understand that before pushing, we check if the stack is already full, because we cannot add an element into a stack if the stack is what? If the stack is full. Then also again, when we want to pop an element, to remove an element from a stack, we first check that if the stack is empty, because we can't remove an element from an empty stack or from an empty container. Then let me move on to explain how a stack data structure works. Over there, I've got 5 containers that I have over there. On the first container that is reflecting empty stack, the variable top will be equal to -1. This means that the stack is empty. But if we want to add an element into a stack, we must first increment the variable, the value of the variable. You must first increment the variable top. So on the second container, the variable top is now 0. Why? We have incremented it by 1. So meaning that we are now adding an element. So when top is -1, it means that the stack is empty. But when top is equals to 0, it means that there is now an element. There is now one element in that has been added into the stack. And also on the third container, top is now 1, meaning that the container is now having 2 elements, is now having 2 items. Then same applies to the fourth container. But on the fifth container, the top is now 1. What happened? We have reduced the value of top. We have reduced the value of top, or we have decremented the value of top by 1. So if we decrement the value of top, it means that we are removing an element from the top of the stack. Moving on, using stack in programming. How do we use stack in programming? Over there, I'm going to explain using C++ because over there, because we are using for our module, we are using C++. We are not using other programming languages. And just know that data structures is not a programming language. When we speak of data structures, we are saying that it is the way in which data is organized. We are defining as the way in which data is organized. So over there, I'm applying C++. I'm going to explain using C++ programming language that we are using. I've just used on C++ programming language hash include IOStream. That is the one that we must first know when we are writing the C++ program. We must start with hash include IOStream, then using namespace std. Then over there I've put hash define max, then I put 1000. Over there I'm declaring a constant that I will use over there, that I will use to make sure that my stack must hold a maximum value of 1000, although a stack must must not have a maximum size, it's not this one is the maximum size of the stack. But let's go to the next part. I've declared an array that I called my stack. That one I'm going to use as my stack. In my program, I've just used an array that will have a size of 1000, that is max. Then I've declared and initialized a variable top. Then I initialized it to -1 to represent that the stack is empty. Then allow me to explain the following operations. The first operation is that to check if the stack is full. How do I check if the stack is full? Over there I created a function that will retain a value that is of bool. When I say bool, I mean that the value that will be retained is either a true or a false. It's either a true or a false. In computer terms, when we say true, we are meaning that the value that will be retained is 1. But when we say false, the value that will be retained is 0. Then over there I said that it will return bool. Then my function is called is full. It is just used to check if the stack is full. Then inside the block of the function, I've just used an if-else statement. My if-else statement goes like this. Inside the condition of the if-else statement, I've just put is top equal to max minus 1. I'm just comparing top with the last position. If top is equal to the last position in the array, it means that the stack is full, meaning that it will retain 1. Why retaining 1? It is retaining 1, meaning that it will be saying that it is true that the stack is full, because this function is used to check if the stack is full. But if that condition is false, it will retain a 0. Then let me explain about how to check if the stack is empty. I've just used that function that is called is empty, that will retain a bool, a bool value, a value that is of bool data type, that is either true or false, that is 1 or 0. Then inside the block, I've just checked if the stack is empty. Then how do I check? I just comparing the value of top to -1. As I explained before, saying that if the value of top is equals to -1, it means that the stack is empty. That is what I've used over there. But if that condition is false, it will retain 0. Why retaining 0? It will retain 0, saying that it is false, that the stack is empty. Then let me explain about removing an element from the stack. I said when we remove from an element from the stack, we use a function that is called pop. Pop will remove an element from the stack, and it will retain no value. That is the reason why I have put void data type. That is the reason why I have put void. Then inside my function, I've just used an if else statement, and then inside the if else statement, I've just put a condition. My condition is saying that is empty. Why am I using that one that is called is empty? Is empty, I'm calling my function that I've highlighted over there on the top right. I've just put the function over there of is empty. If my function is empty, it must display the message that says the stack is empty. So calling that function, it makes us to receive the type. It makes us to receive either true or false. If over there returns true, it means that the stack is empty, because we call that function that is called is empty. Then if the value of top is equal to -1, it will retain 1 to say that it is true that the stack is what is empty. But if it is false, it means that we are going to the else part. Here, if you go to the else part, then we first display that message that says my stack at position top has been removed. Then we decrement the value of top. Then let me explain about adding an element to a stack. When we add an element to a stack, we use an operation that is called push. Over there, I've just used a function. My function name is called push. Then it is going to retain a void. It is not going to retain any value. Then my parameter over there, I said int value. So my parameter is value. So inside my function, before I add an element into the stack, I must check if the stack is full. Why am I checking if the stack is full? I cannot add an item from into a full stack, right? In that way, if I try to add an element into a stack that is full, it will cause overflow. So it is better to first test whether the stack is full, right? So if the stack is full, it means that it will just display a message that will say that the stack is full. But if the stack is not full, then we can add an element into the stack, meaning that we first increment the value of top, then we add the element at position top, right? That is what we can do over there. Then let me move on to explain about accessing the top element. When we access the top element, we use the function that is called pick. That is the function that we have to use when we want to access the top element. So how do we do it? Over there, inside the function that is called pick, I have got an if statement that is over there. I must first check if my stack is empty, because I cannot access the top element from an empty stack, right? If it retains true, it means that the stack is empty. But if it returns false, it means that it will access the top element. Then let me explain about the application of stack data structure in the real world. Although stack is a simple data structure to implement, it is very powerful. The most common uses of stack are to reverse a word. Put all letters in a stack and pop them out. that is where sometimes where we can use stack data structure. Then also again, stack data structure is used in compilers. Compiler use stack to calculate the value of expressions, right? The value of expressions by converting the expression to prefix or postfix form. Then also again, stack data structures are used in browsers, right? Are used in browsers. I can give you example. For example, if you open so many pages on a browser, if you open so many pages, you open the first page, then open second page, the third page, fourth page. But when you want to return to the first page, you must click a button that is used to go back. So meaning that you are going to the previous page, then previous page, until you reach the first page that you firstly visited. Then advantages and disadvantages of stack data structure. It is simple to implement, right? It is something that is straightforward to implement using arrays or linked list, making them easy to use and understand. And also again, with stacks, another advantage for stack for using stacks, there is an issue for memory management. Stack can be used to manage memory efficiently, especially for recursive function calls. Then reversing data. Stack can easily reverse data or processes as the last item added in the first is the first one to be processed. There are so many advantages that we can speak of, but let's go to the disadvantages. Disadvantages of using stack data structure are that there is limited access. And also again fixed size. When we use it may be difficult to use them if we implement using arrays, because the size will be so fixed. It means that the issue of dynamic cannot be used over there. Then another disadvantage of using stack data structure: searching with a stack is not efficient because you can only access elements in a strict LIFO manner, that is last in first out. So it makes it to be more complex to search an element. That makes it to be more time consuming when you want to search an element from a stack. So ladies and gentlemen, thank you so much for listening to this. Thank you so much. Have a great day.